Mm. Um, yes, it is shareable, but I'll not share it right now, Gideon. Share size. We will give you the test. We'll give you the sample exam, the practice exam. Okay, I'll find you one. I'll find you one that is downloadable as a PDF. I just send it to you. You just look at it how it is, but don't stress over it. It's just see how the questions are asked. Knowing how the questions are asked, even without knowing the answers, is also part of exam prep. So don't worry, you'll do so many of them. You will do so many of them, and you guys will be so good. You'll be so good. So now I want us to start our lesson today. It's already 9:09. So we can start our lesson today. And one sec. So and as I had hinted, is that today we are starting a new topic. Okay, today we are starting on a new topic, and our topic today is on networking. So networking, when you're talking about networking, we're generally talking about how devices communicate one to another. And so in this course, we'll be doing a couple of modules. So today we are starting on Introduction to Networking, which I'll be taking you through. Then in the afternoon, we'll be with Joy, will be taking us through networking concepts. I believe, give me a second again, give me a second, another second. Put this one here, I want to check something. My email is loading slowly. So we'll be doing that introduction to networking. That's where we are starting today. So yeah, so we are in week 3. And today we are doing introduction to networking. Then in the afternoon, you'll be looking at networking concepts. And then we continue tomorrow with the rest of the stuff. Give me a second. So if at any point I become unclear in terms of my internet, please just alert me. I have 2 lines of internet. Just in case one of them goes down, mniambie ni shift mbio before things become bad. All right. So just go back up. Okay. So welcome to today's class, and today we want to talk about networking, introduction to networking. So I know some of you might be familiar with this term, networking, and some of you, maybe this is the first time that you are hearing networking in the context of IT, but worry not. Regardless of your level of understanding of this concept, we have a few objectives that we want to make sure that you guys are able to do by the end of this delivery. So by the end of this lesson, you should be able to define basic networking terms. You should be able to explain what the internet is, its purpose and its functions for users, and then identify the main components of a computer network. Identify the main components of a computer network. So, what is the internet? Someone help us define what is the internet. What is the internet? Engage me pale kwa chat or unmute. Niambieni, what do you understand by the term internet? Someone has unmuted? Yes, Rich. It's a group of interconnected networks. Yes. It's a group of interconnected networks. Interconnected networks. Wonderful. Very good. So the internet, simply put, is a combination of all the devices all the devices. And when I'm talking about devices, I'm talking about computers, I'm talking about routers, I'm talking about switches, I'm talking about any device that are connected together are connected together around the globe. And now these computers, like for example, the way I have my devices at my place and you have your computer where you are at, and then another learner has a device elsewhere, your other instructor akopia na devices zake mahali, those devices are connected together. You see, we are all connected, and that is why we are able to communicate. You know, we are able to communicate because we are connected together in the internet, interconnected networks. That was very good, Rich. So when we are talking about the internet, I know this might be a repeat for some of us who already understand this, but when you look at the history of the computer, of the internet, not the computer, the history of the internet, we see that the internet was born right back in the 1960s, and then it has been evolving to be what it is today. You know, it has gone through a process of evolution to become what we see today. So from the very first time, the internet initially, it was just meant to it was meant to ensure that devices within a confined space can actually communicate to each other. Maybe you want to send data from computer 1 to computer 2. You know, that mainframe computer. You remember when we were talking about the history of computers, I told you guys that back in the day, the computer started as one huge and giant thingy that actually occupied like a full room, you know. And now when you want to move data in between them, you get that guys were using what we call packet switching. So packet switching as a theory was tested back in the 1960s. And then after that, we then moved on to the 1970s, where now something new was introduced called the TCP IP protocol that we currently use up to date. Transmission control protocol that we use to date, and the internet protocol that we use was developed back in the 1970s. Sitauliza mlikuwa wapi your time, maybe mlikuwa tu idea. Most of us were not born by that time. TCP IP back in the day. That is when it was developed. Then in the 1980s came dial-up. So dial-up was introduced, and this one allowed for email communication. Dial-up allowed for email communication in the 1980s. You know, then come to 1990, that is now when the World Wide Web, Windows 95, and the Uniform Resource Locator, the URL that we use. Walikuwa kwa magoti bado. Kuna wengine hata hizo magoti bado hatazi kukua. Ama walikuwa kwa magoti za maguka zao. Maybe. But fun fact is that this evolution as it came, you see, things are being improved as we move towards where we are at today. So we have the World Wide Web, we have Windows 95, and the URL being developed around the 1990s, and we get the URL being used around that same time. And then come the 2000s. In the 2000s, networking, the internet, and devices evolved from LAN devices to wireless devices. So when you talk about LAN is all about local area network, and now a newer way of connecting to these devices was developed, called something that we called wireless connectivity. So Wi-Fi, hizi Wi-Fi zenye tuko nazo hizi zilianza kuwa developed around the 2000s, and from that point to date, a lot more has happened. You know, a lot more has happened. So we are being told that the internet as we know it today all started in the 1960s, and it started with the US Department of Defense Advanced Research Project Agency called DARPA, which worked on packet switching theory to send messages between themselves and a partner university. So the US Defense Research Project, this was a project which brought together the Department of Defense in the US together with universities. So they were trying to share knowledge. So to figure out how they can share this knowledge, they came up with what we call packet switching. packet switching theory. So this one allowed them to communicate between themselves. So remember this mainframe computers, zingine ulikuwa unapata maybe the main one was with the Department of Defense, and then another one was in a university. So they were trying to see if we want to communicate, if we want to send something from here to there, can we send it? So that's where packet switching theory came to be. So let me check something here about packet switching. So we are being told that packet switching is a method of transmitting data over a network by breaking that data into smaller units called packets. So you take the full data and then you break it into small bits, and then now you transmit it over the network. So each packet contains a part of the message along with the header information like the source and destination addresses, allowing them to be sent independently and possibly through different routes. Possibly through different routes. Then once they are received at the receiving device, it is reassembled. The receiving device reassembles these packets to form the original message. So yes, so umezituma kama packet, imekuwa split. Then when it gets to the destination, the device at the destination, what it does, it takes these messages and it reassembles them. So that is what packet switching is all about. Then we are told, again, in the 1970s, TCP and IP, that is Transmission Control Protocol and Internet Protocol, was developed in order to link multiple networks together. We have now started coming closer to the internet. Now we are linking multiple networks. So there was that network at one university. There's that network, that main place, let us call the source at the Department of Defense. Now this Department of Defense wants to communicate with University A, B, C, and D at the same time. So what it does, it came up with a way of making sure that these different locations are actually interconnected through that what we call TCP/IP. Now, in the 1980s, in the 1980s, dial-up was introduced as a way to access the internet, and this allowed the revolutionary way the internet and allowed the revolutionary way to communicate across the world using email. So email was made possible by dial-up, which was introduced in the 1980s. So this was possible through what we call the local area network, LAN, local area network, LAN. So we also see LAN being mentioned for the first time in around 1980s. And then come the 1990s, that is when we started having the likes of HTML, that is hypertext markup language, and URL, the Uniform Resource Locator, created to visualize what is called the World Wide Web. So to visualize, to make them visible to maybe output devices, things like screens. And then in 1995, big things were happening, such as Windows 95 and large company launches that you most likely still shop on today. Yes. Big companies such as the likes of akina Amazon.com. Those were the times that they were coming up. And Amazon.com started as a bookshop. Ilikuwa an online book retailer. They were selling books online. Before it became to what we know it as today, that giant e-commerce site. Then in the 2000s, we had the dot-com bubble, and that dot-com bubble had come to its end. By dot-com bubble, we mean the emergence of companies that were now able to sell their stuff online, the emergence of many e-commerce sites. And then, however, even in that bubble, this created a new wave of opportunity for technology. And then networking, the internet, and devices you use today have evolved rapidly since the start of the early 2000s. And you can see that even if you look at your own phone. And kuna watu, but nikisema hii, I might bant. Kuna watu, they were born when smartphones were already here. There are those who were born when smartphones were already here. But there are those who were born we can call it the pre-smartphone era, smartphone area where we had this kind of phones called the touchtone phones. Touchtone. Ilikuwa na buttons. Unafinya inalia ti, 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 ti. Yeah, and by the back then we did not have WhatsApp. We did not have WhatsApp. Yeah, so it was an interesting time, and I'm just amazed at how technology has really evolved to become what it is today. And you see, fact that you have these smartphones is it's not just about the smartphone, it's also about its ability to participate in networks as an interconnected device. You know, so our phones today, we call them internet on the palm. Yani internet mkononi. Internet mkononi, meaning that you can access almost everything that you can access on a machine, on your laptop or on your desktop. You can access it on your phone. And that is very, very important, even in terms of connectivity, in terms of making things seamless. You see, the same meeting that we are holding right now, most of you are connected via your computers and via your computers, I mean desktops, and also your laptops, but there are also those, kuna wale wenye wako kwa tablets zao. There are those ones who are using their phones to access this meeting. So all that was not possible back in the day with the kind of devices we had then, but now things have evolved and technology will continue to evolve. You know, they'll continue to evolve. And when we talk about the evolution of technology, we are talking about technology evolving both in software and in hardware. And in hardware is what I've just given you as an example of our phones evolving to what they are today, and also our computers evolving to what we have today. And when we are talking about the soft bit of evolution, we are talking about networks becoming better. We are talking about the internet becoming more democratized. We are talking about penetration, even penetration of internet, speed of internet, you know, all that improving by the day. So that is what we expect to see as we continue. And networking plays a lot in all of this. In this journey, networking plays a very important role, because it is only through networking that we are able to communicate. You know, I don't know, when you guys were young, I don't know if you used to play this game, ama ni game ya sisi wa kitambo, sisi millennials, wenye ni millennials kwa call hoye. Okay, so there was this game that we used to play. You take something like a kasuku. Should I call it kasuku? Mkebe. Mkebe. What is normally packaged in mkebe nowadays? Oh yeah, let me use something that you guys know. Yogurt. You see that plastic yogurt? You take that yogurt cup, emptied of yogurt, I mean a used cup, then you toboa a shimo, and then you take how do you call it? You take a small stick, tie a string to it. Tie a string to it. Yes, that one, Musembi. Musembi. Nimekuona. You take a string and then you connect it to another cup with the same string, and and then you try talk on this end and your friend listens on that other end. That was you demonstrating. If you ever played that game, that was you demonstrating how networks work, how sound travels through that string. And you see that sound in itself is audio, and audio is just a packet. Everything can be distilled down into a packet. So it is you communicating, and then that one is able to move to that place. You see, that one, that what you are saying here is able to be heard in that other end. Kama hujaicheza hiyo game, na una feel you missed out on something, nunua yogurt mbili, tafuta rafiki mmoja, kuileni yogurt, mkishakula yogurt, make that string and try it out. It's fun. You know, some of us grew up pre-PlayStation, pre-PlayStation years. So that was like our PlayStation. Now, everything that we've discussed so far, it was meant to bring us to this place here, where we are now talking about computer networking. So when we are looking at a network generally on a higher level, when we try to think about networks, you remember what we told you guys is that we try to explain IT concepts using things that are familiar to us. Now, if you are in Nairobi, or if you have been to Nairobi, hata kama hujai kuwa Nairobi, niliambiwa juzi there are two types of people that are in Nairobi. There are those ones who are in Nairobi by birth, and there are those ones who are in Nairobi by bus. Kuna wenye tulikuja Nairobi, hatukuzaliwa huku. So regardless, whether you are in Nairobi or even in the cities that you are, because I think things like road networks have been made possible even in the other far-flung areas of our country. So if you think about those roads, see how a road connects. You see, you can take a road, let's say, there are these roads that we call bypasses. There is the southern bypass, the eastern bypass. Look at that network. You find that in as much as it is a bypass, but it is connected to other roads. There are other roads that you start from here, you exit there, you get here, you get there, all that. Those are examples of networks. That's how you can visualize a network. Or if you are even if you take a drive or you're in a matatu, maybe going to town, you'll see that you start from this road, and then at a place you take a bend or you take a turn, you enter into a different road, and then you take another road and then another road until you get to your destination. Similarly, even the data that we are trying to send over network, it passes through such. It passes through such different quote unquote roads or different highways. Ndio maana saa zingine nasikianga they talk about the information superhighways. The information superhighways. So that is what makes it possible for data to travel with ease. Even as I'm talking to you right now, I'm talking to you from Kiambu, but someone is in Wajir and they are able to get what I am teaching, in real time. And that is very, very important. That is very, very important. So networking is like a highway system that connects cities and states together from one point to another. You see, it connects cities and states together from one point to another. So it is possible for me to start driving, say, from Kiambu and get myself gone all the way to Kisumu, all the way to Mombasa, all the way to this other place. As long as I just have my map right and I have the road right, I'll get to where I'm going. So it is the same way. You can be communicating here and then you get your information traveling to where it is supposed to go. So I hope that one makes sense. Then in the example that you've seen above, point A is your house, which we call the client. And then point B is the grocery store, which you call the website. And then in this example, in order to get to point A, from point A to point B, you will get in some type of transportation. So it can be a motorbike, it can be a car, it can be a train, it can be a plane, depending on how far you are traveling. Then by getting into that mode of transportation, what you're doing, you're sending a request to go to the store to buy what you need. Now to get there, transportation takes a series of roads or networks to get to point B. That is what we just talked about. I've told you, for you to move from, for example, where I am at to go to Nairobi town, I'll need to, first of all, get into a matatu. And then from that matatu, it will now take me through different points before I finally get to Tao. So that is that. So what is computer networking? Now, a computer network is a collection of computing devices which are logically connected together to communicate and share resources. So when we are thinking about a computer network, think of it as a collection of computing devices, and computing devices can be varying in their types. And then these computing devices are logically connected together to communicate and share resources. So from this picture here, from this image here, what you can see, you see an example here. We have a laptop, we have a desktop, then we have a printer, and we have what looks like a server. So you're told that this is the host. This is the host. This is the host. And then the whole of these are your clients. So we have a client, and a client. So an interesting thing here is, and also the client can also be called a node, or any device in a network is actually called a node. So a node refers to any device on the network, and the example can be the likes of computers, routers, and printers. And then you have a host. A host is also a node because it is part of that network. But this one, it has a unique function. It has a unique function because it is what serves, it is what gives the other the other node devices access to resources. So other devices connect to the node so they can access data or other services. So an example of a host node, example of a host node is something like a server, the way I had mentioned a server. So you can see all of these devices are connected to this server. All of these devices that you see are connected to this server. And even these devices themselves, you can find that they are also interconnected to each other, in the sense that, I don't know if you guys have been to an office setup, or I can even use an example which I believe most of you guys have been able to use, a place like a cyber. You go to a cyber, you get that there are so many computers. Those computers are all interconnected together, maybe to a central printer. So you have client A, you have customer A, customer B, customer C, all of them browsing, and then they want to print something. So they'll just ask, nitumia printer gani, which printer should I use in this list, in this drop down list? And then when you send your document, it will be printed automatically. So what is being shared in this network is what? Is that printer. Different computers, but now they're able to share a printer. So that is something that you can easily do within a small network. And later on, you'll be seeing different types of networks. And now that network might fit into what we call a home network. You can even have your home network. And the example that I like using when you're thinking about home networks, just to mention it, is that in your home network, you might find that you have very simple things. Like, for example, you have a router. That router is what is receiving internet and bringing internet into your house, and also sending out whatever you want to send out. For example, if you're sending out an email, it transmits through there. If you're doing a video call, it transmits through there. So that router it's not only serving your laptop or your desktop, it is also serving, say you have a smart TV in the same house, maybe you have a number of mobile devices, you have different people living in the house, and they are also accessing internet from that router on their phone through the Wi-Fi that you've given, or guests wakivisit pia, mtu akaitisha Wi-Fi password, you give them the Wi-Fi password, they are also able to connect to it. You see, now that is what we call a network. And you can have even two small networks like the home network, for example. And we'll see more about that later on when we get to that subtopic. Now, what you see here is just an explanation of what you've said above, and let me just read through it to keep it here. What is computer networking? So this is a collection of computing devices that are logically connected together to communicate and share resources. So an example is like an interstate highway system that connects cities and states together from one point to another. Like networking, it made it possible to be connected in a faster and easier way. Imagine kama hatungekuwa na these highways, how would we be traveling? You get? So how does it work at a basic level? And so it has a node. And a node is like a computer, a router, a switch, modems, printers, which are connected through links, a way for data to transmit, such as cables. So sometimes you can't connect, like, for example, you can connect your computer to your router, maybe through a LAN cable or an Ethernet cable. Then that follows rules to send and receive data. So all of this, there are rules that are already defined that makes it possible for these devices to share data, either to send, receive, or stuff like that. So it also has a host. So a host, as we said, is a node that has a unique function. So other devices connect to nodes, so they can access data or other services. So the main host serves other devices. That's why you hear them called servers. An example of a host is a server, because a server can provide access to data, run an application, or provide a service. So those are three things that a server can do. A server can provide access to data, it can run an application, or provide a service to the other computers. So here is a simple illustration of a basic computer network. And you can see we have a switch here. We have computer A, computer B, and computer C. So these three computers are all interconnected through this switch, and each of these computers has what we call the network card. Network card, the NIC. the network interface card, NIC, the network interface card. So this is the icon for the network interface card, this one and this one. So each one of them has that. And that is what makes it possible for these three devices to be able to communicate to each other. And we'll see more about what NIC does. I remember we touched on it when we were talking about the basics of computers. I think it was on week 1. Yes. So you see, now we are going deeper into that. Now, above, we say above is an example of a basic computer network where a computer is connected through a network interface card and traffic is routed, or switched. It's routed or switched through a switch to its intended destination. So when there are more computers within buildings, computers are grouped together to a switch that is then connected to a router as seen on the next slide. The next slide now we are going to see a different thing called a router. And even before we look at this, can someone tell me hapo kwa chat, what is the difference between, what is your understanding of the difference between a switch and a router? What is the difference between a switch and a router? Someone tell us pale kwa chat. What is the difference between a switch and a router? Somebody? And you're free to Google. Hakuna mwenye amewakataza Google. You're free to Google because we are learning together. Salem umeamua tu went to straight to deep stuff, eh? Umegusa OCI. Umegusa OCI. That's good. One of them is a layer 3 device, another is a layer 2 device. We will see that when we continue. But I want so assuming Salem, I'm asking you that, and I am a HR person, and I'm not IT, sina IT background. So now a router connects different networks, like your home network to the internet, while a switch connects multiple devices within a single network. Very nice. Very nice. Switches connect devices. Switches connect devices. Router connects switches. Nice. Router is a bigger switch. Hey, okay. The router is the gateway. HR bado hajaelewa. Ukianza kuniambia router is a bigger switch, na baki najiuliza so inamaanisha kama router ni this by this dimensions, then okay, kama ni this meter squared or this circumference yake, then nikipata router kubwa kushinda hiyo in diameter, so you mean that one will now become my switch, eh? Ni kama nipike ugali kubwa alafu ugali ndogo kama stew. Niseme now stew is a smaller portion of the meal. It's a smaller portion of the ugali. Guys, we are trying to help you guys. No, mkienda kwa interview msidunde. Msianze kutuambia that in a meal ugali is the bigger portion of the meal and then stew is the smaller portion of the meal. So if I cook a smaller ugali, that one becomes my stew. No. Now, Habakkuk anatuambia a switch is a networking device that connects multiple devices such as computers, printers, and servers within the same local area network. Good. A router is a device that connects multiple networks together and directs data packets between them. A switch connects devices. Juma anasema a switch connects devices within a single network, while a router connects multiple networks and directs traffic between them. Very nice. Rich, a router interconnects switches. A router interconnects switches. Switches which then connect different devices. Well, all right. Good. Very good. Thank you for that. But I'm shocked. Joyce, you kama mko shocked hivyo kama mimi. I'm not seeing any ladies telling us anything about routers and switches. Ladies, mko kweli? Ama mambo na switch na routers mama mwachie boy children. Ninyi mnataka kuingia tukifika kwa the cool stuff. No, tell us. I'm waiting to see at least one comment from the ladies. This is a mixed class, so let us get your engagement. Ivy mko wapi? Hebu represent Chelsea. Hebu represent Gail, Fan. Hebu represent. I want to see what you girls think routers and switches are. Emmy, Angela. I am equally saddened, Joy. I am equally saddened. Ivy, I'm a mock represent. That's nice. A switch connects devices inside one network. A router connects different networks like your home network to the internet. Very nice. Very nice. Very good, Ivy. Very good, Ivy. That is very good. That's very good. So tukiendelea hivyo, please let us get engagement both from our ladies and from our gents, and that will be very nice. That will be very nice. Okay, awesome. So back to this illustration that we have here. Let me check something. Where is that? Okay, good. We are still good on time. So, elements of a computer network. So we can see that we have, on one side, we have computers, A, B, and C. And then each of these computers has an NIC, which you have said is a network. What did you say it is? It's a network interface card, these things that you see here. So each of our computers has that. And I want you to, I want you to mark that, because what you see in the physical, or rather what you see in your on-prem environment, let me call this diagram a representation of what you have in the on-prem environment. What you see in your on-prem environment, it will be replicated in the cloud, the same way you see it here. Maybe you have computer A, computer B, computer C. This might be EC2 1, EC2 2, EC2 3, and each one of them have something that makes it possible for them to be able to access the internet. And then we have a switch. We will try and map and tell you now on the internet or in the cloud, what is a representation of a switch. Then we have a router. You see, we have a router, in which case unaweza pata maybe router represent the internet gateway. Unaona ukiwa kwa cloud. So then we have like that small network on side one, and then we have that other small network on the other side. So mnaziona like ABC forms network A, then DEF forms network B with the same things. They all have the NICs. They both have switch A for network A and switch B for network B. And now these two switches are connected to the router through network cables. So now, through network cables. So the same way that you guys have defined and have said that devices within a local network connect to each other through a switch. And then switches connect to the internet through the router. That is the best way for you to define it. That is the best way. And thank you everybody who participated in that small question. Now let us see what the notes say. Now, as noted in the previous slide, in a bigger network, the computers are grouped to a switch. For example, in the example above, we can see that we have computers grouped to switch A and switch B, which are also known as subnets. So our switch A will be subnet A, and our switch B will be our subnet B. You see, so subnet, and you will get to interact with this word over and over because it's a very important concept in the cloud. So a subnet, just think of it as two words. What do you think a subnet is? Someone tell me, what do you think a subnet is? If I ask you, just out of the blues, tell me, what do you understand by the term subnet? And remember, we are trying to use simpler things to define complex stuff. So what is a subnet? Rija kwa wapi? Rija alikuwa ananiambia he is a network engineer. Ilikuwa ni Rija Masalem. One of you is a network engineer. So tell us, what is a subnet? Small networks, division ya IP networks. So it is like small network, nice logical division of a network. And our ladies, you're still typing. Tuwapatie dakika moja tuone mkirepresent. Okay, we are giving you that 1 minute. The countdown is on. Ladies, let me see. A small network within a network. Thank you, Dan. We are waiting. We are waiting. We are waiting. Niliwaambia, I'm not moving until I see a lady responding. Felix, small part of the net of the internet. Awesome, 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 awesome. Let me check something. Yeah, we have different in different subnet ranges. Yes, and we'll get to discuss that. Ladies, I'm still waiting. Nyinyi mnafanya sisongi. So tell me, what is a subnet? Segment of a network. Thank you. Fan Abby, a subnet divides one large network into smaller, more efficient parts. Sorry. So data can move faster and more securely. Awesome. Thank you, Abby. That is awesome. Thank you. Now we can move. Let me ask something. All right, awesome. So, so yeah, so that is what you're talking about, subnet. Subnet, and I posted and said subnet. So it is a portion of a network. There is a larger network, then that network is divided into subsections. So subnet 1, subnet 2, subnet 3, subnet 4. You can have multiple subnets, and when you guys start going to the cloud, you will see that most times we put our instances and our other workloads, including databases and stuff like that, inside subnets for extra security. You see, for extra security. So we have like two types of subnets in the cloud. We have the private subnet and the public subnet. You know, private subnet and the public subnet. So by just mentioning it again, Juju, because I will get into it when we start talking about VPC. Public subnet, whatever is in the public subnet is able to access the internet bila shida yoyote. Internet, the movement of data can be to the internet and from the internet without any problem, and it's normally connected to the internet through the internet gateway. But now in the private subnet, you put workloads that you don't want. You have a rule that you've placed that hinders these from communicating directly to the internet. So you might have a server there, yes, and there is a server inside the private subnet. But now in this private subnet, this server needs to be updated because unajua patches are being released regularly. So for it to be updated, you use a rule or a resource or tool that allows it to download. It allows it to download the updates and update itself, but no one can access this particular server in this private subnet from the internet. You get, but now you'll get to see how these things work. I just need to mention that now when you come to the cloud, we have the subnets in here, but now the subnets are categorized into two. We have the private subnet and the public subnet. Hope that makes sense. You're to high level, but we'll get to it when we get to the VPC. Don't worry. So these switches sends traffic to a router, which is ultimately a bigger switch with more intelligent functions. So you get. So nilicheka definition ya mtu, but sasa nimeanza kuona it was actually ilikuwa na kaukweli kidogo. So this switches send traffic to a router, which is ultimately a bigger switch with more intelligent function. So there are things that this bigger switch called a router can do that this smaller one cannot do. This smaller one cannot do. Was it Rich when you're at your router is a bigger switch? Yeah, so yeah, okay, awesome. So computer A is a typical node on a network. On the network, it can either be a client or a server. Clients and servers will be discussed shortly. Yes, so it will be discussed. It will be discussed shortly. Ilibidi tu nicheke because it reminded me of something. You know, life is for laughing, I believe. Network interface card, NIC. NIC connects a computer to a network cable. You know, it connects a computer to a network cable. Sometimes, sijui kama any of you has experienced this problem. You discover that your device is not connecting to the internet. Then naenda kwa fundi, then fundi tells you, network cable yako ndo imechapa. You know, not network cable. Computer yako ni NIC yake ndo imechapa, network interface card yake ndo imechapa. So they replace it and then you are good to go. You are good to go. If any one of you has ever done sawa basi nimechangamka. Okay, HR hapa amechangamka. Sawa basi ugali ndogo will start counting as stew. Okay, sawa basi. Tumekusikia Joy. Okay, so we are saying that if any of you is interested in doing a course on networking and just get deeper into networking, the same way we told you about Linux. If you're interested to go deeper into Linux, there are courses Pale Linux Academy, Pale Linux Foundation, sorry, Linux Foundation. So you can go there and pick a course, and some of those courses are actually free. And I'd advise you guys mkue ni wala watu wenye mnapenda kwenda deep in stuff, because ukianza kufanya job yako kuwa mtu mwenye umeinvest in continuous learning, you build on what we have given you. So when you get into that level, and even after this program, you guys will still have access to us. So ukifika mahali and then maybe you want to take a route or you want to study a concept and you are trying to ask yourself where to get this information, both Joy and myself, we have combined experience and skill to help guide you even navigate that. So I hope that one helps you. Hapo ndo penye mtu anarusha ka thumbs up. Imagine tunamwambia will be available for you even after the program. Na mmekauka tu. Mmekauka tu. Rusheni thumbs up. Rusheni thumbs up. Rusheni thumbs up. So what you're talking about here, yeah, I was trying to talk about networking, and I was telling you now, if you want to go deeper into networking, I saw someone mention something to do with CCNA. CCNA is a course offered by Cisco. And when you are doing CCNA, because I've done CCNA 1 myself, when you are doing CCNA, there is something that we call a packet tracer that you use in order to see how packets move in a network. And I've just told you what packet is. The data is taken, it's broken down into smaller chunks, which are now transmitted over the network. So when you are doing one of these practicals, you will be shown how to configure your switches, how to configure your routers, and then you will try to move data from one point of the network to another point of the network. And then you will also be able to do stuff like you'll be picking, there are those icons, you'll be picking things like network interface card, and then you'll be installing it, although virtually, but you'll be installing it to your server or to your computer, so that you make it possible for it to access the internet. You see, then network cables. When it comes to network cables, again through packet tracer, you'll see that there are different types of cables that we use. Kuna hizo coaxial, kuna zile za fiber. There are those many different types of network cables that can be used in a network, and they serve different purposes. You know, they serve different purposes. Wow, wonderful. So you did CCNA 1, 2, and 3 offered by Muhammad Mousa. That's awesome. That's awesome, Basil. That's awesome. I stopped at 1. I did not go for 2 and 3. I just needed to understand something on networks that helps me to become a better DevOps engineer. So that is totally awesome. That's totally awesome. Then yeah, switch A and B connect multiple devices on a network. So that's the work of a switch. And then we say routers connect multiple switches on a network. So that's about that. Now we are going to talk about data and the OCI model. Let me see if we are there yet. We are not yet there. So let us just do data first. Let's do data first. Data. So what is data? In computing, it is bits and bytes, which equal to the value of 0 or 1. You know, computer language, computer understands 0 and 1, zeros and 1, zeros and 1. There are many types of data. So data can be presented in many different types and shapes. So we have character, we have text, we have number, and we have media. Now, an example of media. So media can be distinguished into many different types, like videos, audios, you see, all of that. When you send an email, that is text. When you do your calculation and your arithmetics, 1 + 1, 2 + 2, or you're writing something and then you use numbers, those are the numbers, you know. Then characters are those two special symbols that we use. They can art, they can is it art, they can hashtag, yani alama ya reli, the exclamation mark, alama ya mshangao, you know, all those ones. They can full stop, they can comma, they can backslash, forward slash, all of those are characters. So data can be pictures, documents, code, or text. Data can be sent over a network, and then this can also be saved. Now, I want us to take a short break and just think about what I have talked about. A very short break, not a long one, because pale 9 sikuwapatia break. So it was intentional. I wanted to introduce the topic first before we get to the OCI model. Then when you come back, we will be doing the OCI model. The OCI model. Please take 15 minutes break. Let's be back here at 10:15 sharp. 10:15 sharp, and then we do the OCI model. 10:15 sharp, then we do the OCI model. So see you at 10:15. All right, so I see 22 hands lifted. Thank you, Musembi. Thank you, Sharon. I can see you, Fan, Belinda, Felix, Prudence. Thank you, Brian. Thank you, Priscilla, Mohammed, Emmy, Angela, Salem. Awesome, awesome. Nicodemus, nakuona. So hands have been lifted. Where is Basil? Where is Evans? Where is Silas? Alex Gathuru. Mko wapi? Befalin, Sikuoni, Rich, Clinton, Habakkuk, Mark. I can see you, Purity, Juma, Kevin, Chelsea. Where are you guys? Where are you guys? Where are you guys? Where are you? I believe that break was long enough for you guys to stretch. Whoever wanted to grab a cup of coffee or tea or your favorite beverage, you're able to do it. We are at 28. Don't unraise your hands. Purity Sikuoni, Sandra Sikuoni, Chelsea, Silas Evans. Okay, that is a good number. That is a good number. We can get the show on the road. So thank you, everybody. Thank you for keeping time. Thank you for coming back. So you can unraise your hand. Thank you for that. You can unraise your hands. Mnazi-unraise pia ni kama mlikuwa mmechoka kuziinua. But that's nice. Thank you so much for that engagement. And thank you for keeping time. Awesome. Awesome. Awesome, awesome, awesome. Sijui niseme hii ni good news ama ni gani, but Fan and the other four, please raise your hands. I can see your hands are still raised. But there is some good news for you guys. Brian, Kevin, and raise your hand. Prudence, and raise your hand. Tony, and raise your hand. Sandra, and raise your hand. Yeah, najua mbona mkono ya Sandra ilikuwa raised for longer. She raised it late, so alikuwa nataka catch up. That is good. That is good. Pun intended. Awesome. Prudence, you can raise your hand. Thank you, everybody. So I was telling you guys that there is some good news for you guys. Today, you don't have lab. The units that we are covering today haina labs. Please take that time to catch up with the labs that you did not do. Za huko nyuma, especially the Linux. Especially the Linux. Please take time and catch up with those labs. They are very, very important. It's important that you catch up with those labs. Okay, and if you need our support in any way, if you need us to step in and help you guys even to rerun a lab, we are available to do it. Limona Amy hapa umefurahi mpaka karusha ile that kapati con. Umefurahi mpaka tupa kapati con. Upendi labs ama is it the freedom that now you have to catch up with other labs? I hope it's the latter. I hope it's the latter. So guys, please catch up with your labs. Catch up with the labs, catch up with your cases, and I'll be checking 53 to make sure that what we agreed on yesterday is being implemented right from today. So I'll be checking. And remember, we have offered and said that you can call us into any of your lab sessions. If you're working in your labs as small groups, you can call us into those sessions to help you penye mmekwama, because our interest is to make sure that all of you guys are caught up with the labs and the cases, and we are all moving together. Special shout out to Juliet and Mary. They joined us quite late. They are part of my cohort and they are doing very well. They are catching up very well with their cases. Hiyo ni mzuri sana. They are actually finishing their cases faster than the guys that we've been with from the beginning. So take that as a challenge and let us all do that. So we are continuing with our discussion of networks. You remember, we are talking about networks. Yes, and so now we want to talk about the OSI model. OSI model. So the OSI model in full, let me see, mmefika ngapi sai? We were at 40 something. Okay. Patrick, confirm if lab VPC is still made available in the sandbox environment. Mimi, Jana, I only saw the default one. In the default sandbox environment. So default was lab 1, right? I hope I'm right. This one. Wacha tuiweke hapa kando ifunguange. I'll confirm it for you. That was a good question. We'll check it. Yeah, we'll check it. Wacha ifunguke. Go to student view. Wacha ifunguke tu. Nataka start lab, then we can continue, and then I'll be checking it. So we can say start lab. I'll come back to it ikishaanza. Nikuangalilie what you've just asked. So first lab, do you mean the sandbox or the first lab first? Okay, which lab exactly? It will help to know the lab number. Because first to me is the sandbox environment. Ah, good. Okay. So that's the same one that I'm trying to gurumisha here. That's the same one that I'm trying to gurumisha here, and it is starting. So let it finish kwanza, then we will see. We will see. And just to repeat, if you feel that you are quite behind in the labs and you need help, please feel free to reach out to Joy or myself, and we will be able to assist. Okay. Or if you've already built networks, interesting, we are talking about networks. If you've already built networks with your peers, you can also reach out to them. I know you guys are good and you guys can help each other also. So please do that also. So as that one is opening up, let's look at the OSI model. OSI model. So OSI in full is Open Systems Interconnection. And this model defines standards of how computers can share information over a network. We've been talking from the beginning, and we've been saying that computers in a network shares information with other computers. Like, for example, my computer at this point is sharing information with you via both. You can hear my audio. If my video was on, you will see me as me. You will see a video of me, and then you are also able to see whatever I type. Let's say we are chatting over the meeting chat, or I can send you an email. You see, so the ability of my computer to connect. If my computer was not able to connect to your computer, then it will be impossible for us to communicate. No, it will be impossible for us to communicate. So when you're talking about OSI model, we are saying that this is the Open Systems Interconnection model, which defines a standard for how computers can share information over a network. And the OSI model has 7 logical levels. So these levels are from 1 to 7. And as you can see here from this, how do you call it? From this illustration, we have physical as our layer 1, data link as our layer 2, network as our layer 3, transport as layer 4, session as layer 5, presentation as layer 6, and at layer 7, we have application. We have what? We have application at layer number 7. So that is that. So the way I plan to deliver this particular subtopic is, one, we will go through the notes, and then after we've gone through the notes, I have found a very good YouTube video that explains this. It has +2 animations. I will use that one to reinforce what I'll have, what we'll have discussed through the notes. So we will play that video at the tail end of this presentation. So right now, just know that for the OSI model, we have those 7 layers, and then it ranges from physical all the way to application. And this is important. Understanding the OSI model is very important because it has featured in numerous interviews that I have attended. You will be asked questions about what do you find at layer 4. They'll not tell you that it's the transport layer, but they'll ask you, what do you find at layer 4? What is the name of that layer? What kind of devices communicate at that level? You know, what is the manifestation of the packet at that level? Because as you go through these layers, you'll discover that your packets change its name, or it rather changes its composition. And that is why you find that maybe at this layer, it is in a different form or a different presentation. In this other layer, it's in a different form or a different presentation. So in this illustration that you see here, we have two computers connected in a layer. Connected in a network. Then on the right, we have the source computer. Then on the left, we have the target computer. You can see data leaving our source computer, going through the application layer, all the way to the physical layer. Then it enters the physical layer, and then it goes all the way to that other target, that other target computer. So let us see down here. This is important. I'll not skip this. So we will just read through this pole and just try to internalize it, especially for guys who are coming through OSI today for the first time. So OSI model is the main model used in networking today. The diagram illustrates how data flows in an OSI compliant network from source computer to target computer. So it shows us how data flows from source to target, as you've just seen above. Now, number one, data starts from the source computer. The source computer sends data to the target computer. As the data leaves the source computer, it is processed and transformed by the different functions in the OSI model from layer 7 down to layer 1. During transmission of data, it can also be encrypted, and additional transmission-related information can be added to it. This information is what we call headers. So headers can be added to your data. Aside from encryption, headers can be added to your data. Number 2, next, the data travels to the application layer, that is layer 7. This layer provides the interface that enables applications to access the network service. So that's like the gateway into the network services, the application layer. Then next is the presentation layer, that is layer 6, just below the application layer. This layer ensures that data is in a usable format and handles encryption and decryption. So if you are sending data and it comes to this this layer 6, what will happen there? Encryption. If data needs to be encrypted, it will be encrypted there. But now, if you are receiving data, and then it reaches to that layer, and it was initially encrypted when it was coming from, let's say, the source computer, at that point, that is where it will be decrypted. That's where it will be decrypted. Encryption, decryption, you'll learn more about encryption and decryption when you'll be doing security, a module on security. But right now, just understand that's what happens at layer 6. So let's drop down kidogo. So at number 4, we are at number 4, yeah, layer 5. The data moves to session layer. Session layer is layer 5. And what happens at session layer? This layer maintains the distinction between data of separate application. It maintains the distinction between data of separate applications. It is common for us sometimes to be running multiple applications at the same time. All of these applications are using the same network. And so when it comes to layer 5 is what makes it possible for this for data, for these different applications to be kept separate. Then next is the transport layer, which is layer 4, a very important layer. This establishes a logical connection between the source and destination. It also specifies the transmission protocol to use. Such as TCP. Apart from TCP, there's another transmission protocol that we call there's another protocol that we call UDP. So sometimes you might even be asked to distinguish between TCP and UDP and what they each do. And I know at some point we will come across them. So worry not. Just know that I've mentioned there is another protocol called UDP. So we will meet it later. So transmission protocol, you find it at the transport layer. Then below it, we have the network layer, which is layer 3, which decides which physical path the data will take. As in, data will take which particular path. Which particular path. Then we have the data link layer. The data link layer, that is layer 2. Layer 2 defines the format of the data on the network. It defines the format of the data on the network. And finally, the data travels the physical layer, which is layer 1, which now transmits the raw. Yes, for UDP. UDP is the other protocol. So in the physical layer, sorry, here data is transmitted. So we have transmission of the raw bit stream over the physical layer. After the data has been transformed through the OSI layer, it is in a package format that is ready to be transmitted over the physical network. That's why we are now at the physical network. It is now ready in a form and a format that can now be transmitted over the physical network. Once a target computer receives the data package, it unpacks the data through the OCI layer, but in reverse. You see, now we came from 7 to 1. Now it will start from 1 to 7 as it's going to the destination computer, like you can see here. When data was leaving our source computer, it started from layer 7 to layer 1. But now when it is going to the target computer, it will start now at 1 all the way to 7. You see that? 7 to 1, then 1 to 7. Yeah. That's how data moves. That's how data moves. So data at layer 2 and 3 in the OSI. At layer 2, data link layer, that is our data link layer, a message or data is called a frame. At layer 2, a message or data is called a frame. So frames are associated with the media access control. You've heard of MAC address. So they are associated with the MAC address, which is known as a physical address. So if someone asks you in an interview, what is the physical address of a computer? Know that is what? That is the computer's what? MAC address. And MAC addresses are unique to the devices. Each device has its own MAC address, has its own MAC address. And sometimes when you are trying to send packets of data, it is sent let me just mention this because, again, you'll meet it sometime when you are talking about networking, but you'll meet it at some other point. When you're trying to send out data, that data, you've heard that it is normally bundled with additional information. Part of that additional information might actually be the address where it is sent to. Let's say, for example, computer A is sending information to computer C, but we also have computer B and D in the same network. What stops computer B and D from reading this information is what we call the additional information that this data has. So that data might actually be it might be connected to information that identifies the MAC address of the destination. So when it goes to, you see A, B, C, D, let's say that they are connected one next to another in a straight line. So when it comes to B, B says, no, this is not mine, so it does not read it. It goes to C, C says, yes, this is mine, then it is read there, or it is interpreted in that machine, and then that communication ends there. So it doesn't get to D because it was just meant for C. You see, so a MAC address is very important because it identifies. It identifies yes, so it identifies the devices on our network. So that is very, very important. It's very, very important to remember that. Then when you're talking about layer 3, at layer 3 or the network layer, a message or data is called a packet. The message or data at that layer is called a packet. So packets are associated with the internet protocol, the IP addresses. So packets are associated with the IP addresses. That is very, very important. So just know that at layer 2, it is frame, and frame is associated with MAC address. At layer 3, it's packet, and packet is associated with IP addresses. I hope that makes sense. That makes sense. So that is that. Now, networking components. Networking components. Give me a sec. I check something for you guys. Client, server. Okay. Networking components. Before we do this thing on networking components, let me unshare my screen. I want you to watch that video, because OSI for now imeishia hapo, but I want to just watch this video because I found it to be useful. It will just help you guys to understand something. Let me see, share sound. This one. Share. Awesome.
Are typically described.
Confirm if you can hear something from my end.
From the top layer down.
Can you?
Yes, we can.
Yes.
Okay. So let's
Yes.
Okay. Let's nirudishe nyuma kidogo. So watch it. It's important. It's a bit lengthy, but it's
described
important.
From the top layer down. The layers are described as application, presentation, session, transport, network, data link, and physical.
The global AI market is projected to reach $1 trillion
advertisements.
$770 billion by 20.
Patrick, will you pay a premium?
Sorry?
Will you pay a premium?
Huh?
Anasema will you pay a premium? Wachana na hizo ma-ad. Will you pay premium?
Nimekusikia. We shall see. We shall see. We shall see. We shall see. I should have played it to the Brave browser. Let me see if it's playing. Sinaambia internet yangu imeamua kufanya ile kitu. Is it playing? Let me see.
These layers are provided by a mixture of network card drivers, operating systems, applications, and networking hardware that facilitate the transmission of signals over Ethernet, fiber optic, Wi-Fi, or other wireless protocols. We'll describe the layers from the top down, as the top layer is the application layer, or layer 7. This is the layer that most users interact with and will recognize. The application layer provides network services to the end user. These services are protocols that work with the data the client web browsers such as Google Chrome, Firefox, and Internet Explorer. Other examples of applications that use this layer are Office, Outlook, and Skype. All of those interactive applications provide a set of services that allow the application layer to supply data to and receive data from the presentation layer. The presentation layer, or layer 6, performs the uncomplicated task of syntax processing, or converting data from one format to another. For example, consider you're ordering something from an online store. These transactions are typically handled in a secure transmission, which means that the data passing between the store or the website application will transmit encrypted data to the presentation layer that will need to be decrypted and processed. This layer handles translating the data from the top layer, which is presented in application format, to network format, and vice versa. After the presentation layer processes the data from one format to another, the information is then passed to the session layer, or the application layer, depending on whether the data is transmitting or receiving. At the session layer, or layer 5, the construction, direction, and conclusion of connections between devices occur. This layer supports multiple types of connections, as well as being responsible for authentication and reconnection if a network interruption should occur. After the session is established, the data then passes to or from the transport layer. The transport layer, or layer 4, is responsible for the transmission of data across network connections. This layer coordinates how much data to send, how fast, where it goes, and these sorts of things. Of the most widely known protocols for Internet applications, these services may be provided by Transmission Control Protocol, or TCP, and User Datagram Protocol, or UDP. Other protocols may provide additional capabilities, including error.
Okay, give me a second. So, I should have taken my own advice and used Brave browser, but it's good. So what I will do, I will not let this one play to the end because it's taking time to buffer and stuff. Let me just stop it. I'll share the link with you guys and you guys will be able to watch it. And you will be able to understand what we are talking about, even in a better way. I normally like these animations because they enable us to understand things much better. So I will share the link with you. Uh-oh, what is happening?